In this video, we are going to talk about divided difference table. So we will construct divided difference table from the given data points. First, we will construct a general table, and after that we will look at a particular example. Later on, using this divided difference table, we will construct the polynomial for the given data. So let's see how to construct a divided difference table for the given data. Let's say we have three data points x0, y0, x1, y1, x2, y2. We will put these data points in the form of table. First, we will write x and y values. x0, x1, x2. Corresponding y values are y0, y1, y2. Now, to construct the divided difference table, we will put an arrow between these two y values. So whenever there is an arrow between these two y values, mathematically what you have to do is you have to calculate the difference, always second value minus first. Since it's a divided difference table, so divided by corresponding x values. y1 corresponding x value is x1 minus the corresponding y0 x value is x0. Let's see what actually this is. y1 is f of x1 minus f of x0 divided by x1 minus x0. If you recall divided difference operator definition, this whole term is f of square bracket x0 x1. Let's calculate the divided difference between y1 and y2. So you put an arrow between y1 and y2. It means you have to calculate the difference between these two y values. Always second value minus first, divided by corresponding x values, which are x2 minus x1. We put these values of y in the form of f of x. So we have f of x2 minus f of x1 divided by x2 minus x1. Again, we can write this expression in the form of divided difference operator, which is f of x1 x2. When you open f of x1 x2 square bracket, you get this expression. So this is the column. You can see that from here and here, that in this column each value has the notation that involves two x's, that is f of x0 x1. Next value is f of x1 x2. So that's why we are putting two dots. Means whenever we will be writing the notation for the values in this column, it will involve two x's. Okay, so look at this third column again. So the first value, the first divided difference that you get, has the notation f of x0 x1. The next value has the notation x1 x2. So from the previous notation you drop x0, continue with x1, and the next x is x2. This column now will involve three x values. Let's write the notation first, that what you will have, how you can denote that value. So it would be f involving three x's. Look at the first value in the third column again. F of x0 x1, the first two x's, that is x0 x1. So in the fourth column, which involves three x values, so you will have the first three x's. There are only three x's, so we will put all those three x's x0 x1, x2. This is just the notation of what we shall get here. So the arrow between these two things. So whenever there is an arrow between the two things, you write the second value, which is x1, x2, minus the first value, x0, x1, divided by, now look at this notation, last x minus the first x. Last x is x2 and the first x is x0. So we will put here divided by the last x minus the first x. That's why we had written the name of what we are going to get here first, and then we wrote this divided difference. This is how we construct the divided difference table. Let's very quickly have a look at these notations. So we had the data x0, x1, x2. For y values you had y0, y1, y2, and the first value that you get in between these two for the third column will be of name f of the first two x's, x0, x1. So this column's name tell you that each value that you get in this column will contain two x's, will use two x's. Arrow between these two. So the value that you get, the divided difference that you get here will be of notation f of. So this one has x0, x1. So from this we will continue with x1, dropping x0, and the next x after x1 is x2. Now we have two values. We can put an arrow between these two. So we get only one value for the fourth column. So whatever divided difference we get here, its name is going to be f of the first three x's, which are x0, x1, x2. So these are the notations of divided difference table. Let's calculate the divided difference table for some data in the form of numbers. We have the data x, y, 1, 3, 7, and the corresponding y values are -1, 2, 4. First of all, see that if this data is equally spaced or not. 3 minus 1 is 2, 7 minus 3 is 4. So the difference between every two consecutive x values should be same. Only then we will call that data equally spaced. Since it is not same, so we will not call this data equally spaced. It is rather a not equally spaced data. Let's construct the divided difference table for this data. So the first column after x, y will involve two x's for each divided difference. For example, first you put an arrow between these two. So what you get here will have a name, the first two x's. And before you write the first two x's inside this square bracket, let's name the data. This is the first thing that you should do. x0, x1, x2. We always will start denoting x values from x0. This is y0, y1, and y2. So we have an arrow between -1 and 2. So first, whatever we get here for the divided difference, it has the name, which is f of square bracket, the first two x's, which are x0, x1. Now how do I calculate this? Since the arrow is in between the values -1 and 2, so you calculate the difference between these two values, but remember that you always put the second value first minus the first value, meaning that 2 here is the second value minus, and the first value is -1, divided by, look at this, last x minus first x. Last x is here x1 and the first x here is x0. Last x, x1 is 3, first x, x0 is 1. So you have f of x naught x1 as 2 plus 1 divided by 3 minus 1. So you have 3 divided by 2. That's the first value in the third column, f of x naught x1. The next value will be written in between these two numbers. That's why we are putting an arrow. First, we will write the name of what we are going to get here, which is f of, the previous term has x naught x1. Now we will drop x naught, continue with x1 and x2. This column will involve 2 x's in each term. So f of x1 x2. Now let's calculate this term. Since the arrow is in between 2 and 4, so second value minus first, 4 minus 2 divided by last x minus first x. x2 minus x1, x2 is 7, x1 is 3. Let's calculate this. This is 2 by 4, which is 1 by 2. Now let's calculate the fourth column, which will involve 3 x's. So first, since there are two values, 3 by 2 and 1 by 2, we will put an arrow between these two. Whatever we are going to get here, it will have a name. Let's write that name first. It will involve the first 3 x's, which are x0, x1, x2. And how shall you calculate this? Second value 1 by 2 minus the first value 3 by 2. So arrow is in between 3 by 2 and 1 by 2. So you calculate the difference between these two values. 1 by 2 minus 3 by 2 divided by, look at this notation, last x minus first x. So last x is x2 and first x is x0. x2 is 7, x0 is 1. Let's simplify this term. You take an LCM. 1 minus 3 by 2 by 6. So you have minus 2 by 2 over 6, which is minus 1 by 6. So this is how we construct the divided difference table. So this table has 4 columns. After x and y, you write f of 2 dots, f of 3 dots. So why third column has 2 dots? Because y can be written as f of x, and this f of x could be written as f of square bracket and x. So it means that this column utilizes 1x value. So f of 1 dot. And the next column will be f of 2 dots, and the next column will be f of 3 dots. This is how we construct the divided difference table using the numbers. In the next video, we will see how to construct the forward difference table.